making sense of problems and persevering in solving them. And
Yeah.
sorry. Here's my technological challenge. All right, so we started with a math problem that a younger kid might work on. 43 pieces of popcorn in a bowl, and if you dump them out, how would you arrange them so it's easy for a friend to count? And I kind of like this problem because it has a lot of possible answers. And if you're starting with a kindergarten or first grader, their instinct might be to just lay them all out in ones. But you could lay them out in fives, you can lay them out in tens. That's something you might have to ask leading questions about, like, how's it easy for you to count them? Is it really fastest to count them by ones? What other strategies can you use? And this is kind of, that relates back to the math practice one by making them think about it before they even start. A lot of it is forming strategies. So they could do dot arrays in fives. They could do dot arrays in tens. And most kids, I think my daughter was doing counting by fives and tens by first grade. Bless you.
It's class for me, but
But so there were several different strategies in this problem, but then we were also thinking about a harder problem. Bless you. A problem for grown-ups, and we were actually going to ask to have you guys give some possible answers, but
okay, we will.
anybody want a handout to doodle on?
I gave them
Oh, you gave them one. But I can tell you the way I solved it, I had to stop and think, what do I need to find? I need to find the miles per hour for each car. So it was R1 at X MPH. And then the other one, it gives you the clue, says 10 miles per hour faster. So X plus 10 miles per hour. And then
Bless you many times.
Thank you.
this is, it's the chalk. From there, I came up with, let's see. For me, it worked to set it up algebraically. So
And when I solved the problem, I had to do a picture and like draw an arrow just because it fits so much better for me. She did this, she just wrote down, I'm like, no.
So it was 3 hours is where I got the 3, is that right?
Yeah.
And then that's car 1 plus car 2, and their total distance was 342 miles. So I started by dividing by 3. 14. And then I actually I did it 2 different ways. One time I went through and did 2x plus 10 equals 114, divided both sides by 2, came out with x plus 5 equals 15. 7. I can't do math this morning, apparently.
I know, when you're at the board, it seems
And then
like,
subtracted to get 52.
where's my brain? Did I find it?
And then the other time I just
Sure.
subtracted 10 and then divided by 2. So there were a couple different routes to get there. Do you want to draw your pictures to figure out how
Yeah,
to
go
show
ahead.
us how you figured it
Show
out?
us your picture.
Oh man.
It's a great way to differentiate.
Yeah.
Well, and that's exactly it, is having kids have different strategies before they go in, so that if something doesn't work, they can go back and try another route.
And
that-
also like
that's
check
really-
in, solve it in
Yeah,
two
and
ways.
it's also, I went through and added plugged my numbers back into my equations to make sure
Can't draw.
they were. But that's also kind of the perseverance, if the first thing you try doesn't
Mhm.
work, go back and try a
Yes.
different strategy. and trying to have them think about those strategies before they even begin.
Correct. It's checking and finding more than one way to solve a problem.
And while she's putting up her doodles, like I said, it helps if kids have the strategy before they start and know how to start pulling apart. What do I need to find? How do they relate to each other? And it's good if they think about, have I seen a problem like this before? Do I have something I've done in the past that helps work? And like I said, if it doesn't,
You don't have to
Doesn't
go
work.
all the way. And
Okay.
that would be
that's-
perfect.
Sure. I
Yeah.
can't
Remember exactly what
No,
you're
but that,
doing.
that shows your way of
Yeah.
thinking, so,
And then, I'm really a math person, it just depends on
yeah,
the problem and how it's worded.
sure.
'Cause we have
But
to
these,
pick out.
these are two really different ways
Yeah.
of thinking. One is using a variable,
Yeah,
and
it was kind of nice to,
it depends on
That we
the
both-
age when you want to introduce X. Yeah, okay.
And solve for work by
Mhm.
checking it some other way. And this one too.
Yeah, sorry. So pretty much, how do we apply this as teachers? Our students should be able to understand the problem and figure out the best way to solve it. And work, the biggest thing is to work until it's solved, not just giving up, they have to persevere in solving the problem. We have to push our students to complete tough problems while applying prior knowledge and monitor them while they're problem solving. And then I was reading this article, and like some of the tips is that we have to believe in our students. We have to believe that they can do it, because if we don't believe they can do it, they will not believe that they can do it. So we don't need to baby them. We just need to give them the confidence.
But then going back to little
Okay,
Susie's
yeah.
problem,
Mhm.
you do have to
Yeah.
give them some guiding questions, especially if it's a new concept. But I really like that arrays, because that's a good
Mhm.
introduction to kind of thinking about
Lots of
area and
things, actually.
multiplication
Yes.
and all kinds of stuff, so.
And then I have the actual, this is the actual
Statement.
standard. I can read it. That was a plan.
Sure.
You want to read it? Okay. So, making sense of problems and perseverance on it. Mathematically proficient students start by explaining to themselves the meaning of a problem and looking for entry points to its solution. They analyze givens, constraints, relationships, and goals. They make conjectures about the form and meaning of the solution and plan a solution pathway rather than simply jump into a solution attempt. They consider analogous problems and try special cases and simpler forms of the original problem in order to gain insight into its solution. They monitor and evaluate their progress and change course if necessary.
So that's the thinking back, did I do this before and will it work this time?
Older students might, depending on the context of the problem, transform algebraic expressions or changing the view invented on their graphing calculator to get the information they need. Mathematically proficient students can explain correspondence between equations, verbal description, tables, and graphs, or draw diagrams of important features and relationships. Graph data and search for regularity or trends. Younger students might rely on using concrete objects and pictures to help conceptualize and solve a problem, which is what I needed, even though we're the same. Yeah.
Our brains thought about it
You know,
differently.
It really applies to any
Yeah.
age,
Yeah.
you know.
Mathematically proficient students check their answers to problems using a different method, and they continue to ask themselves, does this make sense? They can understand the approaches of others to solving complex problems and identify correspondence between different approaches.
So, talking to each other about it is good too,
Sure,
discussing different ways we got to the solution.
sounds good.
And that is MP1.
Thank you. Do you have references?
Yeah,
it's
it's-
a
oh.
nice page here.
Just making sure.
Yeah, I was like, I'm looking at it, what the
I haven't switched them over yet, so.
So would you share some of these standard with your students that are doing math problems?
I would not give it to them in the terms,
Not in this paragraph,
but
huge paragraph form.
telling them that a lot of math is figuring out your strategies and
Mhm.
continuing to try.
Being stubborn about it,
Yeah.
don't drop it.
I think this is a,
Pushing yourself to
it's
do
a big
it.
piece of math, is
It is,
persevering in it, because some stuff is gonna take a while to get.
absolutely.
But I feel like you feel so accomplished when you get it, so it's all worth it.
Yeah. No, that, I would share it with them as, this is why we're learning different strategies,
Mhm.
this is why we're talking about it, this is why we're thinking about it, this is why we're doing it different ways. So that you can keep trying
Yeah.
different things, is how I would explain it to.
Part of the
Elementary
challenge is teaching
students.
them to be patient,
Yeah.
so. Thank you.
Thank
Yeah,
you.
whereas this